For 25 years, cosmology had a definitive ending. Physicists calculated that a mysterious force called dark energy would accelerate the expansion of the universe forever, spreading matter so thin that every star would burn out and fade into a freezing, empty void. But data from a massive new celestial map suggests the force pulling the cosmos apart is actively fading. The Dark Energy Spectroscopic Instrument, mounted on a telescope in Arizona, recently cataloged the positions of over 14 million galaxies to track cosmic history. Researchers measured immense sound waves rippling through the early universe's boiling plasma. When the cosmos cooled, these waves froze, creating a grid that dictated where galaxies cluster. By measuring these frozen ripples, astronomers realized dark energy is not constant. It's actively losing its grip. If that repulsive force drops entirely, gravity retakes control. The expansion halts, reverses, and the cosmos collapses back in on itself. The collapse begins in complete silence. Billions of years from now, the growing distances between galaxy clusters will simply stop. The universe holds its breath. Then, the distances shrink. Distant galaxies rushing away from us will slow down and fall backward. As the space between them contracts, the light connecting them gets squished together, shifting from a long red wave to a tight, high-energy blue. Expanding space cools matter down. Contracting space acts as a cosmic pressure cooker. As gravity pulls the entire mass of the universe closer, the ambient temperature of empty space begins to climb. This heat map shows the cosmic microwave background, the ancient freezing afterglow of the Big Bang that currently sits near absolute zero. As the universe contracts, this background radiation compresses and heats up, eventually climbing past the surface temperature of the stars themselves. Stars can no longer radiate their heat outward into a vacuum that is hotter than they are. They swell, break apart, and dissolve into the surrounding plasma. The night sky disappears entirely, replaced by a blinding, inescapable wall of visible light. Long before any celestial bodies actually crash into one another, this intense ambient radiation ignites the surfaces of planets. The cosmos is entirely sterilized. The physical crushing follows the heat. Galaxies are forced into a cosmic pileup, physically shredding entire solar systems apart in the process. The temperatures climb so high that atomic structures fail. Electrons are stripped from their nuclei, and the nuclei themselves crack apart into individual protons and neutrons. And even those subatomic particles eventually dissolve. The entire universe becomes a shrinking ball of raw quark-gluon plasma, mirroring the exact state of its first microseconds of existence. Under Einstein's theory of general relativity, this collapse ends in a singularity, a point of infinite density where time stops and our mathematical models completely break down. But general relativity is incomplete at microscopic scales. Loop Quantum Cosmology predicts that when matter reaches an absurdly compressed state known as the Planck Density, the rules of gravity radically invert. Instead of crushing into a mathematical error, quantum effects within the geometry of space generate a massive repulsive force that violently overpowers gravity. The collapsing matter hits a built-in trampoline. The big crunch does not end in nothingness. The extreme compression provides the exact mechanical trigger required to ignite a new cosmos. The raw, compressed energy of the dying universe explodes outward. It is a smooth quantum bridge connecting a cosmic collapse directly into a new Big Bang. The quantum fluctuations that seed galaxy formation are entirely random. The new universe will have completely different stars, different planetary systems, and potentially different fundamental laws of physics. This concept is known as the cyclic model. It suggests that reality does not have a single beginning or end, but rather goes through an infinite series of expansions, crunches, and bounces. The cyclic model is a strictly testable hypothesis. If the universe bounces, scientists calculate that primordial gravitational waves from the previous cycle should be virtually undetectable today. Global space agencies are actively hunting for this specific lack of evidence. The European Space Agency's Euclid telescope and Japan's LightBird mission are collecting data right now to measure exactly how these cosmic constants shift over time. If the data confirms that dark energy is truly fading, the eventual death of our universe becomes a mathematical certainty. But it also proves our cosmos is just one passing heartbeat in an eternal cycle.